All right, welcome back for another deep dive.
Yeah.
You've been putting in the work, learning all about large language models,
Right.
and now it's time to take things up a notch.
Okay.
We're talking fine-tuning.
Uh-huh.
That's right, actually tweaking these AI behemoths
Yeah.
to become your own personalized tools.
Okay.
Think of it this way.
Mm-hmm.
Pre-training is like giving an AI a crash course in everything.
Okay.
Libraries full of data, all kinds of knowledge,
Right.
but no real expertise.
Yeah.
Fine-tuning, that's where we get specific. Imagine taking that AI
Okay.
and saying, okay, now I need you to be a whiz at summarizing financial reports.
Right.
That's the power we're unlocking today.
Okay. Yeah.
And get this, our sources revealed that by fine-tuning, we're not just talking a slight improvement.
Right.
We're talking turning these LLMs into specialized experts, ready to dive in.
What's really interesting here is the level of control we gain with fine-tuning. Instead of relying on a general-purpose model, we can sculpt its abilities to precisely match our needs.
Wow.
It's like taking a talented musician and helping them become a virtuoso in a particular genre.
So it's not just about making them better in a vague sense. It's about making them better at a specific task.
Yeah.
I'm guessing there's more than one way to fine-tune these models, right?
Absolutely. One of the most common techniques is called instruction fine-tuning.
Okay.
You're essentially teaching the model to follow instructions,
Mm-hmm.
almost like training a dog but with code.
Okay, so how does that work in practice?
It's all about examples. Let's say you want your LLM to be a pro at recognizing different types of legal documents.
Okay.
You'd feed it a ton of examples, each with a clear instruction like, identify the type of legal document
Mm-hmm.
and the correct answer. This is a contract, or this is a will. The model learns from this data, getting better and better at classifying new documents it's never seen before.
So it's learning by example. Does this instruction fine-tuning only work for classifying things?
Not at all.
Okay.
That's just one example. Our sources show it's being used for all sorts of tasks,
Right.
from generating different creative writing styles to summarizing complex research papers, even translating technical jargon with pinpoint accuracy.
That's incredible. So we're essentially molding these LLMs to become masters of very specific skills.
Yes.
But isn't there a risk
Yeah.
that in the process of fine-tuning for one specific task, they might lose some of their general abilities?
You're right.
Like forgetting how to do basic math after mastering astrophysics.
You're exactly right. That's a real concern.
Yeah.
And it's called catastrophic forgetting. It highlights the inherent trade-off in fine-tuning.
Okay.
We gain specialized expertise, but potentially at the cost of broader knowledge.
So how do we avoid creating an AI that's brilliant at one thing but clueless about everything else?
There are a few ways to address this.
Okay.
One is through multitask fine-tuning. Instead of focusing on just one skill, you train the model on examples from multiple tasks simultaneously.
Okay.
This helps it maintain a more balanced skill set.
So it's like giving the AI a well-rounded education,
Right.
ensuring it doesn't become a one-trick pony.
Yeah.
This brings to mind the LONT5 model. This thing's been trained on a mind-boggling amount of data, something like 473 data sets across 146 different task categories. It's like an AI Renaissance person.
Wow.
But here's what really caught my eye.
Okay.
One of those data sets, called SAMSUM, was specifically designed for training models to summarize conversations. What makes it so unique is that it's based on real-world messenger-like chats, the kind you and I might have. So imagine an AI that can perfectly summarize your text conversations, pulling out the key points and insights. That's the kind of capability FLAN-T5 has developed thanks to Samsung.
What's fascinating is that even a model as powerful as FLAN-T5, trained on such a diverse range of data, might still benefit from further refinement for your specific use case.
Okay. It's like having a world-class chef who could still use a specialized course on baking the perfect sourdough bread.
So even with all that general knowledge, there's still room for specialization.
Yeah.
Let's get practical for a moment.
Okay.
Say I'm using an AI chatbot to handle customer support, and I want it to automatically summarize those interactions.
Okay.
So my team can quickly grasp the customer's issue.
Right.
Would a general data set like Samsung be enough to fine-tune for that?
It could be a good starting point.
Okay.
But the language used in customer support chats can be quite specific. There's jargon, abbreviations, maybe even emotional undertones that wouldn't appear in casual conversations. That's where fine-tuning on domain-specific data
Okay.
becomes crucial.
So ideally, I'd want to fine-tune LNTI5 using my company's own chat logs.
Exactly. That
Yeah.
way, the model would learn the nuances of your customer's language,
Mhm.
their specific concerns.
And the terminology used in your industry.
Yeah.
It's like giving that world-class chef
Yeah.
access to your family's secret recipe book.
Our sources actually highlight a data set called DialogueSum,
Okay.
which is specifically designed for support chats.
Right.
They show how fine-tuning FLNT5 with this kind of data leads to dramatically better summaries of customer interactions.
Oh, wow.
They even compared FLNT5's summaries before and after the specialized training, and the difference is remarkable. The fine-tuned summaries are more accurate, concise, and they don't make things up like they did before.
That's great.
Okay, we've gone from the basics of instruction fine-tuning to these incredible models like FLNT5 and the importance of using the right data. It's all starting to come together, but I have one nagging question.
Okay.
How do we actually know if all this fine-tuning is working? How do we measure progress?
That's a great question. And it leads us to one of the most challenging aspects of working with LLMs, evaluation. Unlike a simple calculator where we can easily check if the answer is right or wrong, language is complex and subjective. It's more like judging a piece of art. There's no single definitive measure of success.
Yeah.
But don't worry, there are tools we can use.
Right.
Our sources introduce us to ROUGE and BLEU, two commonly used metrics for evaluating language models. They work by comparing the model's output to human-generated references, almost like having judges score a performance.
So if I'm testing a summarization model, I'd use ROUGE to compare the model summary to a human-written one. And for translation, I'd use BLEU.
Precisely. These metrics analyze things like overlapping words, sentence structure, and overall coherence, giving us a sense of how well the model is doing. But here's the caveat.
Okay.
These metrics have limitations.
Okay.
They can be useful diagnostics, but they don't always capture the full picture. It's like judging a song solely based on the notes played without considering the melody, the rhythm, or the emotion it evokes.
So we can't rely solely on these metrics.
Exactly.
Okay.
For a comprehensive evaluation, we need to go beyond ROUGE and BLEU.
Okay.
Our sources point to the importance of broader benchmarks. Think of them like standardized tests for LLMs.
Okay.
And even human evaluation, bringing in experts to provide nuanced feedback.
That makes sense. You wouldn't judge a painting just by measuring its dimensions. You'd want to consider things like composition, color, and emotional impact.
Exactly. And the same goes for evaluating LLMs.
Right.
It's about looking at the bigger picture, the specific task, and the overall quality of the output.
This has been a truly insightful deep dive so far. We've covered a lot of ground, from the basics of fine-tuning to these powerful models like FLNT5 and the challenges of evaluation.
Yeah.
It's clear that fine-tuning allows us to unlock incredible potential,
Right.
but it's not a simple plug-and-play solution.
Absolutely. It's a process that requires careful consideration, the right data, and a thorough understanding of how to measure success.
Well, I'm definitely feeling more confident in my ability to navigate this world of fine-tuning. And speaking of exciting advancements, in our next episode, we'll be diving into parameter-efficient fine-tuning, or PET, which promises to make fine-tuning even more powerful and efficient.
Wow.
It sounds like a real game changer. But for now, we'll leave you with that thought. Until next time, keep those brains buzzing.
Sounds good. Before we get to PET, let's circle back to those evaluation benchmarks for a moment.
Okay.
You mentioned standardized tests for LLMs.
Yeah.
What makes them different from those quick checks with ROUGE and BLEU?
It sounds like we're moving beyond a simple pass or fail.
Right.
And getting into a much deeper analysis of what these models can actually do.
That's exactly it. Think of these benchmarks as comprehensive assessments, designed to push LLMs to their limits and reviews their strengths and weaknesses across a range of tasks. They go beyond just measuring how well a model summarizes or translates, delving into things like reasoning, common sense, understanding, even the ability to detect bias.
So it's not just about spitting out words that sound right.
Yeah.
It's about understanding meaning, context, and those subtle nuances of human language.
Exactly. And the fascinating thing is that these benchmarks are constantly evolving.
Right.
Pushing the boundaries of what we expect from LLMs.
Wow.
It's like a continuous competition driving innovation and setting new standards for AI performance.
This is all starting to paint a picture of how complex this field really is.
Right.
It's not just about training models. It's about truly understanding how they learn, how they perform, and how we can measure their capabilities in a meaningful way.
It's a journey of exploration, and the more we learn, the more we realize how much there still is to discover.
All right, I'm ready to keep exploring.
Okay.
I think we teased something called parameter-efficient fine-tuning, or PEFT, earlier. What makes this technique so special?
PEFT is all about efficiency and tackling that issue of catastrophic forgetting we discussed earlier. Remember how we talked about full fine-tuning being like renovating an entire house, which can be time-consuming and disruptive? Well, PEFT is more like a targeted remodel. We're making strategic upgrades without overhauling the entire structure.
So we're being smarter about how we fine-tune, focusing our efforts where they matter most.
Precisely. Instead of updating all the parameters of a model, PEFT techniques modify only a small subset, which dramatically reduces the computational cost and minimizes the risk of disrupting the model's existing knowledge base.
Color me intrigued. Can you give us a peek under the hood? How does PEFT actually work?
There are several different approaches, each with its own unique mechanism. One fascinating technique is called adapter modules. Imagine our LLM as a vast network of interconnected pathways with adapter module. We strategically insert these small, specialized components into the network. Kind of like adding express lanes to a highway.
So instead of rerouting the entire traffic flow, we're creating these dedicated pathways for the new information to travel.
Exactly. These adapter modules are designed to learn the nuances of the new task without interfering with the model's core functionality. It's a clever way to add specialized skills without disrupting the existing knowledge base.
This all sounds incredibly efficient, but does it actually work?
Yeah, it does.
Do these PEFT techniques deliver on their promises?
The research is quite promising. Studies have shown that PEFT techniques can achieve performance comparable to or even surpassing full fine-tuning, but with significantly fewer parameters being updated. This translates to faster training times, lower computational costs, and a reduced risk of catastrophic forgetting.
So we're essentially getting the same, or even better, results with a fraction of the effort. That's remarkable.
It's a testament to the ingenuity of researchers in this field, constantly pushing the boundaries of what's possible. And what's even more exciting is that PEFT is still a relatively young field with new techniques and refinements emerging all the time.
It sounds like PEFT has the potential to democratize access to LLM fine-tuning, making it more accessible to researchers, developers, and even hobbyists who might not have the resources for massive computational power.
Absolutely. It's an exciting development that could open up a whole new world of possibilities for personalizing and specializing LLMs.
Well, you've definitely piqued my curiosity.
Great.
I'm eager to learn more about the different PEFT techniques and how they're being applied in the real world.
And we'll certainly delve deeper into those specifics in our next episode. We'll explore the nuances of adapter modules, prompt tuning, and other cutting-edge techniques that are shaping the future of LLM fine-tuning.
I can't wait. But for now, we'll let our listeners digest all this amazing information about fine-tuning and evaluation. It's been an incredible journey so far, and we're just getting started.
The world of LLMs is vast and ever-evolving, and we're thrilled to have you along for the ride. Stay tuned for our next episode, where we'll unpack the intricacies of PEFT and its implications for the future of AI.
Until then, keep exploring, keep learning, and keep those brains buzzing.
Welcome back to the deep dive. Before we were talking about some really interesting stuff, parameter-efficient fine-tuning, or PET. It sounds like the secret sauce for getting incredible results from LLMs without needing a supercomputer.
It really is a game changer. We were talking about how full fine-tuning can be like a major home renovation, expensive and disruptive. PET, on the other hand, is more like a strategic upgrade. Maybe adding a solar panel or two.
Just enough to get the specific benefits you're looking for.
So we're not tearing the whole model apart, just making a few key adjustments.
Exactly. Remember those adapter modules I mentioned? It's like inserting specialized components into the model's architecture, allowing it to learn new tasks without messing with its existing knowledge.
Let's break this down a bit more. How do these adapter modules actually learn and adapt?
Think of them like mini neural networks,
Okay.
each trained to handle a specific task.
Right.
They're integrated into the larger LLM, but they operate independently,
Okay.
learning and adapting their own parameters
All right.
based on the new data they're exposed to.
So it's like having a team of specialists within the larger model, each with their own expertise.
That's a great way to visualize it. And the beauty of this approach is that these adapter modules are incredibly lightweight,
Right.
requiring far fewer parameters to be updated compared to full fine-tuning.
That's where the efficient part of PEFT comes in, right?
Exactly.
Less data, less computing power, faster training times, all without sacrificing performance.
Precisely. Our sources highlight studies where PEFT methods have achieved results comparable to or even better than full fine-tuning.
Wow.
But with significantly fewer resources required.
Right.
It's a win-win situation.
This is all starting to feel like the future of fine-tuning.
It is.
What are some of the other PEFT techniques researchers are exploring?
There's a technique called prompt tuning,
Okay.
which focuses on optimizing the prompts we feed into the model. Instead of modifying the model itself, we tweak those initial instructions to elicit more accurate and relevant responses.
So it's like finding the magic words to unlock the model's full potential.
That's a great analogy. It's all about framing the task in a way that allows the model to leverage its existing knowledge most effectively.
And are there any other PEFT approaches worth mentioning?
Another intriguing method is low-rank adaptation, which involves compressing the model's knowledge into a smaller, more efficient representation, allowing for faster fine-tuning without sacrificing accuracy.
It's like creating a streamlined version of the model optimized for specific tasks.
Exactly.
Yeah.
It's a fascinating area of research with the potential to make LLM fine-tuning even more accessible and scalable.
Well, we've gone from the foundational concepts of fine-tuning all the way to the cutting edge of PEFT. And it's clear that this is a field that's moving at lightning speed. I'm already imagining the incredible applications that will emerge as these techniques continue to evolve.
The possibilities are truly mind-boggling. Imagine personalized AI assistants that can seamlessly adapt to your specific needs.
Wow.
Whether you're a writer, a researcher, or a business professional.
It's like having a team of AI experts at your fingertips.
Exactly.
Ready to tackle any task you throw at them.
And the best part is, you don't need to be a machine learning guru to harness this power. The tools and resources for fine-tuning are becoming more accessible every day.
This deep dive has given me a whole new appreciation for the potential of LLMs. It's not just about what these models can do today. It's about what they'll be capable of tomorrow as researchers continue to push the boundaries.
It's an exciting time to be involved in this field, and I encourage everyone listening to stay curious, keep exploring, and never stop learning.
Well said. To our listeners, we hope this deep dive has sparked your imagination and given you a glimpse into the incredible world of LLM fine-tuning.
Absolutely.
Remember, the power to personalize these incredible AI tools is within your reach.
It is.
So go forth, experiment, fine-tune, and see what amazing things you can create. We'll be back soon with another deep dive into the ever-evolving world of AI. Until then, keep those brains buzzing.